The next section is on hyperbolas. So a hyperbola has the property where the difference of the distance from two fixed points, or what's called the foci, is constant for all points on a hyperbola. And it has some applications because it has a reflection property just like ellipses and parabolas. And it can be used in certain telescopes and navigation systems. So our hyperbolas are going to either open up left and right or up and down. And these are our formulas. So if it opens up left and right, we use this formula. Up and down, we use this formula. So you may want to pause the video and check out all of this information. A lot of this is kind of similar to the ellipses. So if you've watched the videos on the ellipses, it's kind of similar. But pause the video and check out this information. And then also there's a diagram on the next slide. So if you want to pause it here and check out this information and compare it to this information, that could be good. So the negative is in front of the y term. So the x squared is positive. So that tells us that it's going to open up left and right. So let me write that. The x squared is positive. So the shape is going to be like this. It's going to open up left and right. Okay, so my information, h is 0, k is -2, a is 2, and b is 5. So my center is 0, -2. It opens up left and right. The horizontal distance is 2, and the vertical distance is 5. So my center is going to be right here, and my horizontal distance is 2, so here and here, and my vertical distance is 5. So it's going to be here and here. I'm going to use this to draw a box, and that box is going to help me draw my hyperbola. So I'm going to draw a rectangle. So this isn't actually part of the hyperbola, but it's going to help me draw the hyperbola. So I'm drawing this rectangle, and then I need to draw diagonal lines through this. So it's going to be kind of hard on my whiteboard app, but let's see how it looks. There we go. And like that. So if you have a ruler, you can kind of use that to make better lines than I'm making right here. Okay. Again, this is not part of the hyperbola. This is just going to help me draw the hyperbola. So these diagonal lines act kind of like asymptotes. Actually, they are asymptotes. And this is going to be opening up left and right. So it's going to start here, and it's going to kind of follow that asymptote. And same on the other side. when it opens up left and right like it is here, the transverse axis is the horizontal. So from here to here. So that's going to have a length of 4. And the vertices will be here and here. So that is -2, -2, and 2, -2. So that makes the conjugate axis the vertical axis. So that's going to have a length of 10. And these will be my covertices. So then lastly, I just need to figure out my foci. So c is equal to the square root of 4 plus 25, or the square root of 29. So 0 plus square root of 29, comma -2, 0 minus square root of 29, comma -2. The square root of 29 is 5.385. So my foci are going to be horizontal from the center, and 1, 2, 3, 4, 5, it's going to be like right here, and then 1, 2, 3, 4, 5, it's going to be like right here. And again, it doesn't have to be exact, as long as it's close, then that'll be okay. So this is our hyperbola.